Hey everybody, here's part 1 of tutorial 3. So first of all, I've just started with the structures that we're familiar with. We've got a jit.world. I'm going to rename it because I already have a world of that name. Call it jit.world t3. There's my window into that world. Now notice when I create a new world, even though this toggle is on, my world is off. Why? Because the on message, the 1, was sent to the previous world and I've recreated it. So I'm going to turn off my toggle, turn it back on, and now I see, you know, this new world is running. And I have familiar structures here. I have an SF play 2 channel with a large number here for the memory buffer and a 1 signaling that I want a time outlet. I have a snapshot tilde connected to the middle outlet of my jit.world, and I'm dividing by 1000 here to give me seconds, so a display of seconds of the elapsed time of this audio track. Now I'm going to add a few things right off the bat here. First of all, right now we don't have a way to change volume unless we change it here for the whole patch. But I want to introduce a new object which is called live.gain. And live.gain tilde becomes a set of level meters and a fader that allow you to control the volume of the sound. Whenever you create a live.gain, make it wide. Because there's only 2 inputs on the top and they're easy to find, but you have 5 outlets on the bottom and you only want to use the first 2 of them, and then once you've made the connections you can squish that object narrow again, but make it wide to make your connections and then make it narrow. Now what does this do? This allows us to see the volume of the sound and turn it up and down. So let's take a sound here, drag it in and start it. And now I can fade that sound down, fade it back in, and importantly I can see that this sound is actually playing, which is something we haven't been able to do before. Notice I did something a little bit different here. I did seek 3000. Previously we've been working with seek 0. Seek 0 takes us to 0 milliseconds into the file, the beginning of the file, and if we listen, there's dead space at the beginning before the drums come in. How much dead space? About 3 seconds. So instead of seeking to 0, I'm going to seek to 3000. I'm going to seek to 3000 milliseconds in, and that's going to start me right at the beginning of the sound, instead of having to wait through that silence. So what I'm doing here, as you can tell also, is I just have a drum part. Right, this is the beginning of our working with stems. And this is part of the reason why also we need the live gain, because I can take this whole structure, copy it, connect my same seek and my same pause to it, and add another sound file. And as you can see here, I've got the stems for this song. I've got bass, drums, guitar, and then song, which is everything else, vocals, synthesizers. And I just put them into another SF play, connect both SF plays to the same output, and now, when I start these with the Seek 3000, these 2 sound files will start, and I can control them independently. And I can do this with the remainder of the stems so that I have independent volume control of each of the 4 stems. So I'm going to take my SF play, and I'm doing this copying by holding down the Option key, clicking and dragging. I can also just Command C and then Command V. That's also another valid way to copy. I can also Command D, which is another option, valid way. And if I want to make multiple connections with a single chord, I can hold down the Shift key, make multiple connections, and then to erase a chord, you can hit Escape or you can Command click in the blank space. So make multiple connections. And now my pause and my seek are connected to all 4 of these players, and then I'm going to connect all 4 of the players to my audio outputs, like so. I have all my connections there, and then I'll drag in the other audio files. I have guitar.aiff and song.aiff, and now I should hear the entire song. And I can isolate each track individually and listen to it.
When something's going wrong, you must whip it. Now whip it into shape. Shape it up.
And these are not quite raw stems, they're somewhat processed stems of this song. See, they're already in stereo, whereas, for instance, the voices would have been recorded in mono on a single microphone, and the drums would have been recorded in more than stereo, probably across 5 mics. So these are semi-mixed, but we've got independent channels for 4 main areas of the songs: drum, and we can actually comment these. Drum, option click and drag, bass, guitar, and everything else over here. Now, one of the first things I want to show you, now that we have this, obviously this is going to be a very powerful tool for us. Our screen is already full. And this is one of the problems we're already starting to run into in Macs. What do? We have, this is just something, this is just a starting place, right? This is just playing back our 4 stems. And our screen is already full of stuff. So there's a very handy function in Macs that we haven't looked at that is called encapsulate. And it allows us to take any part of our patch. We could take this whole sound thing that we just created, and we can say edit encapsulate or Command Shift E, and it sticks it inside an object. I call it P sound. And there, that whole thing is inside there. If I double click it, it comes up in a new window. So this is how we deal with the complexity of patches, is we put things inside subpatchers, and we're going to see this in another mode shortly. So my entire sound playback portion of the patch is now tucked away inside this P, and if I for any reason need to undo that, I can simply say edit de-encapsulate, and everything will pop back out, and I can edit encapsulate and everything pops back in. And as we know in the sound, in the convention of the class, this is in all caps because I can call this whatever I want. It doesn't matter, it's arbitrary. But that's my sound player right there. And you see what it does? It automatically creates an outlet of the patch so that this time outlet comes out of outlet 1 and flows to the snapshot tilde, and I can create additional inlets and outlets into this patch if I want them. So for instance, if I want, let's say I want my Seek 3000 to be outside the patch, I can simply create an inlet under the plus menu, plus inlet, makes an inlet that I can connect to my Seek 3000 so that I have a way of starting and stopping things from outside the patch. I can create inlet 2 to my pause button. And then here's a new object that we haven't looked at, which is just B for button, where if you have something you want to fire off, you can just connect a button to it. All my sound files need to be reloaded. Drums, bass, guitar, and song. Great, works perfect. Also, one of the things that we've been noticing is that a whole bunch of things need to be connected to this middle outlet of the jit.world. For instance, let's say I'm going here and I want to do some analysis. I just want to get the average amplitude of each of my stems. So I do an avg tilde of this. This is my average drum amplitude, my average bass amplitude, my average guitar amplitude, and my average everything else amplitude. Now I need to make a whole bunch of connections from here, from my middle outlet of my jit.world into this subpatch. So I can create a third inlet here and connect it to all my avg tildes, and then I can go out of my patch and connect this to this, and I'm just creating more mess and more patch cables. And it works to do that, but there's a better way to make connections. You can make connections wirelessly using send and receive. So I can call this send, I'll just call it frame. Again, this is an all caps meeting. I can call it whatever I want. Send frame. And then wherever I want it to go, receive frame. Whoops, got to spell receive right. I before E, except after C. Receive frame. And now I have this much nicer way to make that connection without creating too much more mess. I'm sending my frame from here and receiving it over here so that I don't have to create a new inlet and create all those additional patch cables. So I've got my 4 AVGs, and I can use send and receive again to get them out. I can say send bass so that's drums. Send drum, send bass, send GTR, and send song. I'll call it song. So I've managed to do all my sound analysis in my sound patch without needing to create tons of inlets and outlets. And out here, I can do these as receives. And note that S and R are your abbreviations for send and receive. So this is exactly the same as if I were to type out the REC, I before E, except after C, receive, song is the same as just R, song. And there's a lot of objects in Macs that have shortcuts like that. And each one of these is going to show me the average amplitude of each of the stems. Multi-slider, which is a nice way to visualize numbers so that you can see them graphically. So here we can get little level meters on our stems. And also we can, of course, use our floating point number boxes to monitor them as well and see what's happening here. I'm shift clicking to select multiple and making them all a bit wider. And of course, what we didn't use in here is we didn't use the cross tilde. So we could actually use the cross tilde here to isolate the kick drum out if we wanted to. We could use like cross tilde 200. And put in another AVG here that just gives us access to the kick drum. And of course that needs to be connected to the receive frame. And as always in Macs, it's easy to create a mess, so we tidy things up by making some space so the patch becomes a little bit easier to read. And a lot of people, when I say this to you, you say, oh, it's fine, I don't mind. That's okay. But also do it, because we're just at the very beginning, and you don't mind now, but getting into good patching habits is going to help you when these things start to actually get complex. Because even though this looks complex, this is actually quite simple. Command J will fix the width of all of these objects to make them a little smaller. So you can arrange things in the way that makes sense to you. Command J. And Command Y lines things up. There. Now that, to me, is a much more readable patch. Another thing you can do is you can Option, click and drag, and then right-click to change the color of things. I like to sometimes color my patch cords just so I can tell that they're doing something special. So I just made those yellow so that I know that they're my receive frame into my ABG tildes. And now I've got a new thing here, which is kick, and I should see that as a separate level coming in. Nice. I'm going to show you something that's going to help you to look around your world, which is jit.gl.handle, which you attach. You can attach it to anything, but I think you should attach it to your world for now and give it a reset button. This is going to allow you to just take your world and spin it around and look at it from different angles without having to necessarily move your camera around. So jit.gl.handle sort of lets you inspect your world, and then you can always reset it back to a normal view. We want to put some lighting enable on this cube so that the default lighting of the world gives it some three-dimensionality. And when you click and drag on your jit.gl.handle, you can hold down Option to zoom in as well. So it just gives you a little bit easier way to look at things in your world. So if we wanted to create a continuous motion of this cube, and we hooked it up to our snapshot tilde, we can move it in a continuous way. For instance, along the x-axis. But it's going to be a linear movement, not a cyclical movement. So let's start my music. So my cube is moving in response to the time of the sound file moving forward, but it's going to keep moving in a straight line. It's going to keep moving in the x dimension positively, in a positive direction, as long as the song keeps going. It's never going to come back onto the screen. So how do we turn a linear motion like that into a cyclical motion? Sine is always going to give us a cycle between -1 and +1 as a linear number moves forward. So take a look at this. The cube's going to just keep oscillating back and forth in response to the time moving forward. So sine takes a linear progression and turns it into a cyclical progression, or you could say a circular progression. So this is to move x and y using sine. We'll find that it moves in a diagonal. Right? It's moving from the top right corner, +1, +1, to the bottom left corner, -1, -1. So if we were to take it And so there's our solution to moving in a circle, right? Drive the x with the sine and drive the y with the cosine. Or if we want our circle to be in depth, we can say drive x with sine and z with cosine. And now it's a circle that's moving away from us and then moving towards us and away. And we can reset our handle to see this more clearly. It's moving circularly on a flat plane. Or it could move in a circle like a Ferris wheel. So sine and cosine combined create circular movement. And again, here's a nice opportunity to just encapsulate a lot of stuff. We can just take all of this positioning stuff that's going on, and we can just say edit, encapsulate, and call this circle, and now all that stuff is just stuck in there and we don't have to deal with it anymore. If we double click, we can get to it, we can edit it, we can change the format, but we've got an inlet and an outlet that's doing this processing for us, and it's all tucked inside this box so we don't have to deal with it. So the next thing I want to look at is I want to look at gate. So gate allows us to pass information or not pass information based on some condition. So for instance, we could have this motion only happen at certain times. We can put a gate here, and the right inlet of gate is the information we want to turn on or off. And the left inlet of gate is our control. And it's controlled with a toggle, with a 1 and a 0. So I'll start the music, and when I turn the gate on, the information is passing through. And when I turn the gate off, the information is not passing through. Close the gate, open the gate, close the gate, open the gate. So then I can have a condition under which I want the gate to open. For instance, when the kick drum hits. So when I can say when the kick drum is greater than let's say 0.08, change,
Whip it good. I said whip it. Whip it good.
So the rotational information is only passing through the gate when the kick drum hits. Let me show you one more thing to close out this first part of the tutorial, which is adding a material to your shape. So we say jit.gl.material, and we just attach the material to the shape, and now this has some materiality to it, some quality to it. I'm gonna just home this, make myself a little position 0 button, click it, yeah, and then reset this, and now I have the cube in the center, and we can see the cube has some shininess to it now. And in fact, one of the things we can do with jit.material is change the shininess. Default shininess is 60, and so if you want something really shiny, you can give it like a shininess of 50, and that's going to be a very, very shiny. See how shiny that surface is now? That's your shiny cube. And now what we do with the material, it gives us more than just shininess. It allows us to map imagery onto the cube. So I can take any image. I can take, for instance, the Devo album cover. I have it here somewhere. And just drag that album cover right into my patch. Create a button, again the same button with the B. Connect that to the image. Put the image into the first inlet of the jit.gl material, and bam, now we have Devo on our shiny cube. That's pretty neat. It does some odd mapping things that we won't deal with right now. For right now, what I'd recommend is to not use something like this, but to instead take a more abstract shape like this until we deal with UV mapping. And when we put that on, it's going to look good on every face of the cube. Quite beautiful, actually. Now you see there's lots of inputs to the material because there's lots of other possibilities for ways in which to map imagery onto our shapes, but for now we're not going to deal with that. We're just going to use this first input so we can get shapes onto the cube. And there's only, or any of the objects. And there's one other thing I'm going to tell you about this, which is the image is going to stretch. For instance, if I double the width of this cube and make it a rectangular solid, the image stretches. So this is something to take into consideration. And again, if you're using sort of patterned images as I am here, it looks pretty good when it's stretched. All right, so that's where I'm going to leave it for the first part of this tutorial, and there'll be a second tutorial where we get into sort of the main new concept for this week.